Okay, here's the solution to that problem at the end of the notes. Remember the problem? We were asked to find the number of 5-digit pins, no repeated digits, where not allowed are the following. No first digits can be 0, no third digits 2, and no fifth digits can be 5. All three rules have to be obeyed. So for example, here's a couple of pin numbers that are fine. 13490. You can check the digits 1, 3, and 5, and there's none of the rules 0, 2, or 5 don't show up on the 1, respectively 2, and respectively 5 digits. And also there's no repeats. This one's fine also. You can have a 2 in the last spot, just not in the middle. And there's no 0 there and no repeats. And then here's 3 that break the rules. The first one's a problem because it has a 0 in the first digit. The second one breaks all 3 rules. It has a 0, a 2, and a 5. So it's bad for 3 reasons, but it definitely breaks rules. And that last one breaks a couple of rules. It actually has repeated digits, 5, 5, and it has a 5 in the third digit, so we don't want that. So the last one, however, we can get rid of it by starting out with a set that doesn't include the repeated digits at all. And that's what I suggested in the notes. We should look at a universe which is all of the pin numbers, U, that just don't repeat digits. And that would be one that we found similar to before. Oh, and I think we actually found this exact one. It'll be 10 per mute 5. So they'll have 10 options, 9 options, 8 options, 7 options, 6 options for the 5 digits, and that's what it comes out to. Now we have to get rid of all of those rule breakers, the ones that have that first digit, third digit, or fifth digit incorrect or illegal. So the way that you can do this, though, is use the shortcut. And that means that I'm going to count up, first of all, how many things are in A. The first digit is 0. So if the first digit is 0, I'll just go ahead and fill that in. In other words, there's only one option for that first digit. So the options 3, 4, 5, there's only one option for the first digit, and then the other 4 are all completely free, available. But A only has the first digit equal to 0. And it doesn't say anything about the third and the fifth. They could be 2 or 5. But still, no repeated digits are allowed. So there will still be 9 options, 8 options, 7 options, and 6 options, just like for the big set. The difference is that I've already used a 0. There's only one option there, and then I have 9 remaining digits I can use, then 8, 7, 6. Okay, so I can figure out what that is. It's 3024. I might need to get out the calculator for some of these, but that previous one had an extra 0 on the end, and it included the 10. So remember, I multiplied these numbers together down here. Just didn't show all my work, but that's how you get that 3024. All right, and same for B and C. Now, we can save some time here. So, B and C are going to have exactly the same answer as the number of things in A. It would be as if you were drawing the decision tree for them, but you pick for B the 2 in the third digit, and then fill in the rest. 9 times 8. There's only one option for that. Times 7 times 6. So again, 3024, and C will have the same the same count exactly. It's putting a fifth digit in the last spot. And that would be, put a 5 there, and then 9 times 8 times 7 times 6. Oops. It is a problem here that I'm showing blanks to fill in to make my pin number, and then underneath them I'm writing the numbers of options that there are. It's easy to get those backwards. And in this case I almost made a mistake, but there's only one option if I know that the fifth digit is 5. So I put a times 1 there. Multiplying those together gives me 3024. So I'm multiplying together these. I put boxes around them occasionally, but it might get hard to see. The blanks correspond to what I'm allowed to put in, and underneath there's the number of options. All right, now if you look back in the notes and see that the shortcut involves now looking at all the intersections of these sets. So I think this would be a good place to pause, and then the next thing that I'll do is work out the intersections. But you can work ahead a little bit if you want, see if you get it right.